Quantum?
tunneling.
In which Planck's constant, why Planck's constant should come there?
That was just part of the Schrödinger equation to figure out the probability that the electron is on the other side.
Which subject is this?
Physics.
In physics, in which subject?
Quantum mechanics.
Quantum mechanics. Now, you tell what is Planck.
Oh, I'm not sure what Planck's...
No, but whatever you know.
About Planck's constant? That it's a constant and it's like 0.6 point something something something.
So I want to know which context it is coming.
What do you mean?
Ask what is Planck's constant. Let us see how to answer.
Hey Google, what is Planck's constant?
Here's the definition of Planck's constant. A fundamental constant equal to the energy of a quantum of electromagnetic radiation divided by its frequency with a value of 6.626 times 10⁻34 joule seconds.
So, how does it start? Equal to the energy of a quantum of electromagnetic radiation. You understood? So, what does it mean? The Planck's constant is associated with the energy.
And so the energy with...
When anything radiates, there is an energy. Right?
Whether it's like solar energy or radio waves.
If I am hitting you, there is an energy which I am using. Right? Only one hit. What is the frequency then? No frequency. Only one hit. There are two hits. In between there is a time gap. Assume the time gap is 1 second. And in 1 second I am hitting you 10 times. Same force. So what is Planck's constant says, no? If you hit 2 times, Planck's constant is higher. If you hit many number of times, Planck's constant is less.
So the less amount you hit, the more Planck's constant is.
Yeah. So the impact of any activity of radiation is measured in terms of the Planck's constant. You understood?
Yeah, kind of.
Frequency is how many times you are going to hit during a period, right?
Yeah.
So frequency will come in the denominator here. Correct or not? You have the formula?
This is Schrödinger's equation. Planck's constant is h over 2. So wait, hold on, sorry. It's h over 2 pi. So this h with the line through it is h over 2 pi.
Okay, that h is the Planck's constant. Yeah, that's what I'm saying. So h increases. That means too many times it has happened. So what is that for? What is that you are trying to do in this?
This is basically calculating the energy in a subatomic particle, like an electron.
How do you measure it?
You measure energy with kinetic energy and potential energy. So the second part of this is put the potential energy, and this is the first part of it, which is the kinetic
energy. Okay.
Which then I know the equation and the parts of it, which I wrote down.
But what are you trying to do? What are you trying to?
It's so in quantum tunneling, there's the probability wave that an electron might be in, and when an electron hits a potential barrier, it has this exponential decay of probability that it will end up in the barrier, but exponential decay never really reaches 0. So there's a possibility that that the electron will pass through the barrier and come out on the other side with like a little probability that it might do that. So the equation basically shows when it's passing through the barrier, how what the probability is that it will pass through the barrier.
Who gave you this idea?
Of
Hmm.
quantum tunneling.
Hmm.
I was just looking around at physics topics and saw it, so I decided to look into it.
But how are you going to show this? Visualize it. Are you able to visualize yourself?
Yeah.
You explain to her
Okay, so basically,
the whole thing.
okay. Imagine that you have a ball. Okay. Just imagine that there is a wall and you're hitting a ball against the wall repeatedly. And all of a sudden, the ball transports from hitting the wall to it goes through the wall without damaging it in any sort of way. So at one point you're just bouncing it here against the wall and then it just passes through. Well, it wouldn't really happen in real life. It's basically what happens with quantum tunneling. So then imagine a hill, or with a steep drop off here. If you dropped a ball here, it would roll down and then come up at the same height you dropped it because of conservation of energy, and the amount of kinetic energy has, for it to go over the hill, it's the amount of kinetic energy it has needs to pass the potential energy of the hill. So to get it over the hill, you'd have to hit it with more force to get it over. But then with a quantum particle, this gets replaced with a potential barrier and then the particle.
So if you hit the particle fast enough, it'll go through the barrier.
No, that's
What is quantum?
quantum. It's
Meaning of quantum?
includes. I read it somewhere and then I forgot.
Having to do with the atoms.
See, this is a wave, but it doesn't move like a uniform thing. It goes by quantum. One moment, then it takes rest. And the rest bunch will go. That's what quantum mechanics talks. So the impact on one quantum will be slightly higher than a smooth flow. No? Continue.
Okay, so anyways, so you have the electron and the potential barrier. Before you go into all of that, you have to imagine you can't pinpoint the exact location of where an electron, proton, or neutron is. So you have to imagine it more as a wave, which is a probability wave of where the electron might be. Points of low are low probability of where it could be, and the high points are where it's highly supposed to be. So imagine instead of an electron, a wave hits the barrier. So the Schrodinger's equation, shown here, explains the amount of energy here. Well, when the electron hits the wall, it doesn't have enough kinetic energy to overpower the potential energy of the barrier. So when it hits the wall, it has this exponential decay of energy it has. So to get through the wall, so the wave hits the wall, and then it has this exponential decay of energy. So an exponential decay will never really reach zero. It'll always be like, the closer you get to zero, the farther out it'll get. So it never really reaches no energy here. So when the exponential decay comes back out, there's still a tiny probability that the electron will be past the barrier and go through. And that's basically quantum tunneling. don't know. Thanks. I didn't.
You ask what is quantum tunneling?
Hey Google, what is quantum tunneling?
According to Wikipedia, quantum tunneling or tunneling is the quantum mechanical phenomenon where a subatomic particle passes through a potential barrier.
That's the graph I was trying to explain.
Hmm?
That's the graph I was trying to explain. But anyways.
And Schrödinger's equation describes the
exponential decay
decay.
and the wave function.
Where is it used?
Schrödinger's equation.
No, where is the whole thing is used?
To figure out all the things you need to know about a subatomic particle. Its wave function, the amount of energy it has.
So your interest is in which subject now?
Right now, I mean, just at the moment, I really want to understand quantum tunneling.
Have you heard about photonics?
No.
Water purifier,
Yeah.
which is the best water purifier today.
The best water purifier?
Could boil water and that purifies it.
Just chlorine?
Hmm?
Chlorine?
Which could be the best method for purifying water.
Boiling.
Inserting chemicals?
No, boiling is one, and then vapor reconverting. Right?
Yeah.
But that's not a practical solution for supplying water for people. No, you will see a lot of water purifiers along with the cooler put in common places. Earlier it used to be water passing through small porous media. You know what's porous media?
Netting.
Lot of solid items, so in which it goes through, then all that.
Rocks and sand.
Yeah, sand or something like that, you know. But then the present methodology, which is most advanced, could be where the water molecule itself will not go through the filters. The filters are so small, H2O cannot pass. H2O is, what is water, right? Suppose you push water here, it will get split into
Hydrogen.
hydrogen and oxygen. Because hydrogen and oxygen is passed through this, you have to forcefully push it. Right? So once you pass through this, on the other side again hydrogen and oxygen will rejoin. And that will become the purest water. So we have filters and stoppers to stop atoms. But do we have the stoppers to stop electrons?
Not
You
really.
understood what I'm asking?
Not really. You'd have to build a well that's
No,
in
see, assume I have got an electron. Electron size is this much. If I have to cut this electron, what should I do? I need a knife smaller than electron. Such knives are available.
There are.
In such places, it is not hit by once. Assume you want to cut something very small pieces. What do? You keep on cutting it, right? So such mechanisms are called oscillators. So you have accelerators in different places. The facility itself is called oscillator. But once you oscillators, anything cut, there can be a fission or fusion. So it's generally put underground, 200 meters under the ground. So if anything blast comes also, it will go there. Correct? So I don't know how, where is it used, where is the application. I'm only looking at it. Are you able to visualize stopping an electron movement? I'm trying to visualize it. You understood? In which scale you are working, you know? The electrons of what size?
Nano.
Hmm?
Nano.
Nano is 10 power minus 9. It's much less than that. Nano,
Minus 39.
minus 13, 13, 15
Atom.
atoms.
Atomic.
Yeah, atom. Atomic level is that. But then electron is much, much smaller than that. Right? You must look some videos maybe available. Have you seen?
Videos on this? Or, yeah.
You seen?
I've rewatched them a lot.
Huh?
I've watched them and rewatched them, trying to understand it.
So who helped you?
Google, technically. But
Just check if that you could locate. Let us see.
the video,
Hmm.
I'm just like,
Have you seen the DNA, genomes and all? On DNA? Pattern on YouTube?
Yeah.
Okay.
Not in like real life, but in like cartoon versions.
Not cartoon, the real.
No.
Scientific versions. Must look at scientific versions.
I've seen the diagrams, but not like in real
No, it's a
human.
beautiful videos of the genome projects. The DNA pattern. Got it?
it was the very first one.
Hmm?
The first one.
This?
Yeah. That was one of them.
This episode is sponsored by Brilliant. Hi guys, Jade here. So a few weeks ago I made a video on the Schrödinger equation, and in it I said that if we place an electron in a box, the probability that it could be found outside the box is 0. And a lot of you commented with questions like, oh, but what about quantum tunneling? Isn't there some cases where the electron can tunnel outside of the box? So I thought, what the heck, I'll just make a whole video about it. It's super cool, and I will answer that specific question at the end of the video. But first, what is quantum tunneling? Well, the short version is, in regular classical physics, if you have a ball at the bottom of a hill, if it doesn't get a big enough push to get over the hill, it's kind of just stuck there. Putting this into physics talk, if the ball doesn't have enough kinetic energy to get over the potential energy of the hill, it'll never get over, like, ever. But of course, in quantum mechanics, things aren't so simple. If we replace the ball with a quantum particle like an electron, and the hill with some kind of potential barrier, even if the electron doesn't have enough kinetic energy to jump the potential barrier, sometimes it can end up on the other side. This is called quantum tunneling, and in this video, we're going to see how it works. So now, the long version. So one of the biggest differences between quantum and classical physics is that quantum physics is probabilistic. Unlike a ball, we can't pinpoint exactly where an electron is. This comes from the Heisenberg uncertainty principle, which says that we can never know the exact position and momentum of an object. It's not because our measuring devices are too crappy or because we're too slow, it's just something fundamental about the laws of nature. But not all hope is lost. Maybe we don't know exactly where the electron is, but we know with a pretty high probability that it's around here somewhere. We can actually model these probabilities with a wave, or more technically, a wave function. This wavy cloud gives us the probabilities of where the electron is likely to be. So now, instead of imagining a particle traveling toward a barrier, imagine a wave traveling toward a barrier. Now, when this wave collides with the barrier, because the electron doesn't have enough kinetic energy to make it over, it gets reflected. Oh wait, what about the whole tunneling thing? Well, there's this secret property of waves you probably didn't learn in school. Light is an electromagnetic wave, so let's imagine what happens when we shine a light beam through glass. When we shine a light beam through a piece of glass, at the boundary where the glass meets the air, the light beam will bend, or refract. You may have noticed this effect if you've ever looked at a straw in a water glass. The visual illusion comes from the bending of light at the boundary of two different mediums. In this case, air and water. But refraction isn't the only thing that can happen at a boundary. Light can also get reflected. The amount of light which is reflected and refracted depends on the angle that the light hits the boundary. All mediums have a certain angle where 100% of the light beam is reflected. This is called total internal reflection, and you may have heard that when this happens, 100% of the incident beam goes back into the reflected beam. But that's not true. These are Maxwell's equations, and though they may look innocent, they form the entire foundation of classical electromagnetism. Remember how we said that light is an electromagnetic wave? This means that the way light behaves in different scenarios can be predicted and modeled by solving Maxwell's equations. Now, when we solve these equations for the case of total internal reflection, we get something very interesting. This! Isn't that interesting? Instead of there being an abrupt drop-off where the light hits the boundary, there's this very quick exponential drop-off. This is shown by this term here. I know this looks super complicated and, well, it is. So let's just get rid of all that mumbo-jumbo here and just focus on the bit that matters. This is a graph of e to the power x, which as you can see models exponential growth. But the term in our equation is e to the power negative x, which is simply the backwards version of this, exponential decay. So we have this tiny little drop-off wave here. This is called an evanescent wave, which in my opinion is a very suitable name. The word evanescent means soon passing out of sight, memory, or existence, quickly fading or disappearing. An evanescent wave is pretty much exactly what it sounds like. It decays incredibly quickly, lasting only a few wavelengths before vanishing, so we can't usually see or detect it. But if we place another material sufficiently close to the boundary of the first, sometimes the evanescent wave doesn't decay completely to zero before hitting the next material, so it can then continue to travel onwards. This is called frustrated total internal reflection, and I recommend looking up a demo on YouTube after this. I would have shown you in this video, but for anyone who's read my Twitter bio, you know that experiments are not my forte. I actually did try it and it just didn't work. Mild digression. Optics was one of my favorite subjects in university, and we did a lot of work on evanescent waves, but I never really got a physical intuition for why they're there. The only answer I ever found is because Maxwell's equations say so, like when you solve the equations you end up with this decaying exponential. But other than that, I can't really see a physical reason for why a wave can't just abruptly stop at a boundary and change direction. So if you do, please explain it to me in the comments. Okay, digression over. This wave might be puny, but it's the reason behind why quantum tunneling is possible. Remember that we're treating our electron as a probability wave, which means that when it gets reflected here, an evanescent wave forms at the boundary. If the barrier is thin enough, sometimes some of the wave actually makes it through. So if some of the wave makes it through, and this wave represents the probability of the location of the electron, then there's some very small but non-zero probability that our electron is over here. Even though this probability is tiny, because there are usually so many quantum particles involved in any physical process, the effects of quantum tunneling are large enough to be essential to nuclear fusion in stars, spontaneous mutation in DNA, and scanning tunneling microscopy. It may seem startling that we're treating the wave function exactly like an electromagnetic wave. It's hard to imagine something so abstract like the probabilities of electron locations as a real physical thing that travels and reflects and tunnels. The truth is, scientists still don't know exactly what a wave function is. They don't know whether it's purely a mathematical tool we created to help us predict things about quantum objects, or whether it's a real physical wave. But what they do know is that it can be modeled pretty much perfectly by wave mechanics. When we solve the Schrödinger wave equation for the electron inside the barrier, we get this exponential decay, which is exactly what we would expect of an evanescent wave. Speaking of Schrödinger's equation, in my video about that I said, if we place an electron in a box, the probability that it could be found outside the box is zero. And a lot of you are confused because what about tunneling? Well, the truth is I didn't specify this very well. In a lot of university degrees, a particle in a box is the simplest case we use to analyze Schrödinger's equation, but it's actually a particle in an infinite potential well. So instead of this being a box, look at it as a well with infinitely high and thick walls. In tunneling, the barrier needs to be thin enough so that the evanescent wave doesn't have time to completely decay to zero before reaching the other side. Only then can it propagate onwards. With infinitely high and thick walls, that's obviously impossible. So yeah, my bad, didn't specify infinity. In my last video, someone commented asking whether it was futile to try and truly understand quantum mechanics without doing the math. And my immediate reaction was, yes. While you can learn the catchphrases and get an overall gist of what's going on, to really get that gut feeling of understanding and intuition, you need to work through the problems and see what the equations tell you. I didn't really understand the Schrödinger equation until I solved it myself. Brilliant.org is a learning website with an entire course dedicated to quantum mechanics. It starts with the very first experiment, which reveals strange quantum behavior, and takes you all the way to Schrödinger's equation. It has this interactive quiz style, which I love because you can work through problems at your own pace and check your understanding at every step.
When you switch on the light, yesterday I was telling you get light, right? What is light?
Light. It's a wave.
It's a wave. So when the bulb is on, what is happening here in the atmosphere around it? in the room? You get light. Light is wave. So what is happening?
Waves are traveling.
Waves are generated. Correct? How does the wave generated? How is it generated?
When
How does it happen?
so when a proton is
See, inside your bulb, there can be a filament, or there can be anything which heats it up or make the electrons to vibrate. So there are a lot of movements of electrons happening here, right? Right? But how does it that makes a vibration here? Because it's covered by a glass.
well, if there's so many electrons that are bouncing off inside there, some of them go through. So
You mean electrons will go through this?
go through the glass.
Go through the glass. See, that is where the original concept of material and energy has to be understood. Anything which is material need not move, but still you can make an impact with energy. I have shown you that sound is coming, right? We are not seeing the vibration, but there is a vibration. Correct? The air is moving inside. That vibration created comes in a specific frequency, it becomes wave. Similarly, the light also creating a frequency, that's an energy. That energy to vibrate everything outside also. It need not physically move. So the waves which is explained need not be that same electron which is inside is coming out. It is only creating a vibration. That's why you are considering an electron, no electron then. Then they talk about it's a wave.
So does the
Electron itself doesn't come.
But it's saying that the wave is a probability of where the electron is. So does the electron move in a wave? Or does
See,
it move straight?
that is what the concept is. And wave is a pattern of transmission of energy. Any energy needs, I don't have to travel, I can push you. You are not traveling, you can make a vibration there, no? So it's a continuous pushing. The material is not moving. The electron need not move, but electron can push. The impact can be the vibration. When the impact is vibration, the air around this place is moving. That is why you are seeing it as a light. And that frequency, right? That frequency can be 0.4 to 0.7. What is 0.4 to 0.7 micrometer? This is the visible region. Visible region on the light. I am explaining through light because it's you can visualize it more. So there is 0.4 to 0.7 micrometer in which it moves. Therefore you are able to see. Correct? Now assume this medium is not very good. Now you are seeing white light there in the sky. Why is it white?
Because it has all of the colors.
0.4 to 0.7 full is seen by you. Okay. When Vibgyor, violet, indigo, blue. This mixed blue is what you are seeing actually as the blue. It is not the perfect blue. Is it the perfect blue?
What's the perfect blue?
Perfect blue is, you want to see perfect blue? How do you know? Do you know how to make a perfect blue in your on a computer?
No.
It's 00225.
Yeah. So when you make a 00225, you know that is perfect blue, right? So you can change the color as you want. In a drawing, you can change your color the way you want to change. What is that picture here? So you can take it in home. Oh, I came all on a sudden. I became so blind, not able to see anything. Should I insert some shape? Shape is better for you to visualize, right? Now this I wanted to change. Format shape. Go to fill and change this color, right? More color. So this is the combination.
002.
So if I put 0, this 196 is not enough. 255. It will become perfectly blue. Why 255?
250 is maximum.
See, these are all working on bit rate. 8-bit is the display. 8-bit is what? 2 power 8. 2 power 8 is 0 to 255. So total number will be 256. 2 power 0 is 1. 2 power 1 is 2. 2 power 2 is 4. 2 power 3 8.
16.
2 power 4 16. 2 power 5
32.
no 32. 2 power 6 64. 2 power 7 128. 2 power 8 is 256. So all the displays use 8-bit. And RGB 3 8-bit will make it a 24-bit display. So what is my computer display?
24.
24-bit. So I can use RGB in any number of combinations from 0 to 255 and create how many colors? 256 into 256 into 256 number of colors. Getting? So this blue, what we are seeing is a combination of violet, indigo, blue. And when the whole atmosphere is polluted, all these will be cut. And what is given is only red. That's why when sometime the sky looks red and orange red, Vibgeo or no, the last one will be orange and red. You will see nice, beautiful orange red color sky. What does it mean?
It's really polluted.
Yeah, the whole atmosphere is polluted.
But you saw that in the sunset, that doesn't mean pollution, right?
That is also pollution.
Really?
No.
Hmm?
It's also pollution, but no. See, there is pollution. The sunlight is here and earth is here. How much distance it is traveling? The distance from earth to sun. Millions of kilometers, right? But actual refraction, because of this the color change is happening. Refraction happens only in the atmosphere because rest is vacuum. No pollution, nothing will be there. So what is this 140 kilometers? That's atmosphere. So whatever we are seeing is because of the atmosphere and the refractions. What we are seeing is in fact the atmosphere. Beyond that it is invisible. It is black. Light irradiation will not come. What are we seeing? Because of the light comes here and irradiation comes, we are seeing the light. Otherwise we will not see. Are you getting? Now, in the morning and evening, where is your sun? Is it on top of you?
No.
It's here.
Yeah.
Correct? So when you are standing here, you have to cover only 140 kilometers. When the sun is here, you have to cover how much?
Extra.
Equivalent to the radius of Earth. That will be 6,000 kilometers. In the evening and the morning, the light is not traveling 140 kilometer. Instead of that, it is traveling
600.
6,000 kilometers. Because it is 6,000 kilometer, even a small portion of pollution can create a lot of reflection. That's why I answered yes and no. Got it? Not necessarily around your area is polluted. If it is polluted somewhere in some other region, now assume you are looking for sun. Now the sun is on the top, right? Evening when you are looking, I don't know which are the cities are there on that area, no? So any place where it is polluted can cross. Therefore, not doesn't mean your area is polluted. From you, when you are looking through this, if there are anything which is in your west,
So is there a place on Earth where you can see the sunset and it's only blue?
100%. Sunset and sunrise will be so beautifully bluish.
Where?
Go to the sea, nearby sea. When you are seeing from here and the atmosphere is above the sea only. Go to Indian Ocean. Look from the eastern coast of India. Almost it's water. So you'll see beautiful bluish. But still there will be something, right? But very, very less. I remember once one of my friend sent a beautiful picture saying, beautiful Sharjah. He was traveling from Dubai to Sharjah. Sharjah to Dubai. He stays in Sharjah going to Dubai. So when he took a picture, beautiful sky. Immediately I wrote, totally polluted. Got it? Beautiful for us is when it is totally red, no? Looks beautiful. So what is happening? All this color which you are seeing is a visualization of wave pattern in which irradiation happens, and the reflections which is coming as light is what you are recording. So don't say that the sun rays are red. Sun rays are not red. Sun rays are having not even the optical region. It has got wide variety of wavelength. Heat wave is another wave. Correct? So when the light is coming from the bulb, we don't say that the electron is coming from the bulb.
A wave.
The waves get it vibrated in a space, and the energy is so much it can vibrate in the whole room, but it cannot vibrate 20 meters away. It can vibrate only 10 meters away. Got it? But any electromagnetic energy is so small and electrons are small, we don't know how much it is vibrating, what frequency it is vibrating. Therefore, what is vibrated inside and what is vibrated outside, is there a difference? Whether the same fellow is coming out or not. It could be because electromagnetic energy doesn't have any specific name tag or size tag. Electrons are all electrons. So you don't know whether that electron is inside is what is there outside. How do you distinguish? You understood what I'm saying? You have a stopper and then says that it is the same. How do you know? Because you cannot even count what is going there, what is coming out. Assume you are throwing 1,000 balls against a wall. And there are few same size, same type of balls are there on the other side. How do you know which ball is that? There is no vacuum anywhere, right? Where you are going to find. Electrons are there everywhere. Electromagnetic energy is there everywhere. If there is a vacuum, definitely it cannot make a vibration, it cannot make energy, it cannot transit anything. Quark.
What is quartz?
Quark.
Quark. Oh.
QARK.
Hey Google, what is quark?
Quark is.
According to Wikipedia, quark or quark is a type of fresh dairy product made by warming soured milk until the desired amount of curdling is met and then straining it.
Principle, right?
Who is that man who died recently? One scientist.
Hey Google,
Gibbs,
what is quark's principle?
Gibbs boson.
Sorry, I'm not sure how to help.
No, boson is not.
Hey Google, what are quarks?
According to Wikipedia, a quark is a type of elementary particle and a fundamental constituent of matter.
That's not fair. How come it give me dairy product?
Because you love dairy products, she loves energy and physics.
Makes sense.
Look for ECG Sudarshan. You heard about him?
No.
You must know all these people. Yeah. ECG Sudarshan. He is no more. I heard his lecture when I was 22 years old.
EC.
ECG. His name initial is ECG.
ECG. Then
Sudarshan.
there you go. On the top one.
You want to learn all this, you must know these no? People. He died last year. Read about him. I had the fortune of sitting in his class.
The first to propose the existence of tachyons, particles that travel faster than light, developed a fundamental formalism called dynamical maps to study the theory of open quantum system. Has been credited with numerous contributions to the field of theoretical physics, including optical coherence, Sudarshan Glauber representation, VA theory, tachyons, quantum Zeno effect, open quantum system, and Lindblad equation, spin statistics theorem, non-invariance groups, positive maps of density matrices, quantum computation, among others. His contributions include also relations between East and West, philosophy and religion.
You understood? The physics will not be able to answer few questions. Philosophy and religion will answer questions. So these are all like Maya. You know what's Maya? Illusion.
I mean, I saw that in I think it was Russell's paradox.
Is he from Madras?
He is from India, from Kottayam, Kerala. He was in Math Science Institute, Madras. Indian government almost gave a institute for him to work.
Why didn't they? Why didn't they?
He gave an institute, that Maths Institute is actually ECG Sudarshan's brainchild. Mathematics and physics, only two subjects are taught in that institute, and that he was heading that. So I remember meeting him, talking to him when he was director there. He gave a lecture. He would have got a Nobel Prize. ECG Sudarshan, but his two students got. He couldn't get. ECG Sudarshan Nobel Prize, you write. Google. Sudarshan and Nobel Prize, that's good enough. I'm sure there will be. He got many awards equivalent to Nobel Prize, but not Nobel Prize. Is there anything? It went into controversy many times.
It's talking about his death a lot. Oh, nominated for a Nobel 9 times.
Can you imagine somebody from India like this? You never heard, no? So it's close to your interest. So you will become another physicist with a lot of contribution. Who is the man who did a lot of research in physics and then got Nobel Prize from India? All these topics which I talked. is his contribution. Sir C.V. Raman. Never heard about these people. Tisha, when you love this subject, you must know the name of these people, right?
Sir Chandrasekhara Venkata Raman was an Indian physicist born in the former
And he's the one
Madras
who
province.
got Nobel Prize. And beautiful, you know, how do you remember him? Right, 28th February. You check the dates, it will tell you. I should write and you can find out. He took birth in 1928.
1888.
88,
November 7.
yeah, 1888. 1888, correct? 1888. He got Nobel Prize in 1928 or 30?
1930.
30. But that invention happened in 1928. 2 years after he got. That's why I asked you.
What was the invention on?
Invention on radiation.
What did he invent?
You know what he invented?
No.
You take a glass of water and pass light through this. The refraction will be there. What is shown there, right? He was putting a pen and it was moving. Lately shifted. That shift is because of refraction. So he found that through water, when it moves like this. Through alcohol it will be different. Through petrol it will be different. Through diesel it will be different. Through oil it will be different. The medium,
So, is it like based on viscosity?
yeah, based on
Yes.
different characteristics. One of them could be viscosity. And that effect of light is called Raman effect. Ask what is Raman effect. Let Google know.
Hey Google, what is Raman effect?
According to Wikipedia, Raman scattering or the Raman effect is the inelastic scattering of a photon by molecules which are excited to higher energy levels.
Because of the medium, right? It's a great joke on Raman.
What is
He identified how Raman effect is in alcohol, how Raman effect is in water, how Raman effect is in. What is Raman effect? The light pass, how it affects the light in the medium. So there was a party in which the host said he found how Raman effect in alcohol. Now we will find how alcohol affects Raman. Now you will never forget, no? Correct? Now you will never forget. Raman effect is, yeah, that's how we make people to remember. Yeah. So, 82nd year he died, correct? Check.
1970.
How many years old?
82.
82. So 28, 82. There are so many things on him like that you can study. I used to give lectures on him. His birthday is celebrated as
November 7th.
not birthday. His invention of this Raman effect is celebrated as the Science Day for India. Check.
Wait, what is February 28th then?
That is the day he invented.
Oh.
But award he got after 2 years. Nobel Prize he got after 2 years. Expecting Nobel Prize, he booked his tickets also. But he couldn't get. First year he expected, he didn't get. Second year he got.
So, do they only award Nobel Prizes if you're still alive?
No, not necessarily.
Okay.
Who got Nobel Prize for physics and chemistry?
Physics and chemistry? I mean,
You are my children now. Now you should start learning all this. It will be interesting. Okay? Madame Curie and Marie Curie.
Oh yeah, on the thing on radiation and gamma ray or something. I was thinking of them, but I didn't think it was them.
And they studied in which college, you know?
In France.
London. Check Madame Curie, Marie Curie. King's College or Imperial College. That's where my son studied.
nice.
So you must aspire. They used to keep talking about these stories to them when they were young.
University of Paris.
No.
Flying University.
Then
Paris, Flying University.
Madame Curie, Marie Curie, London, then. Right? What they there?
Talking about the school on her. Marie
It's
Curie
a
education.
Charity.
Yeah. Education.
Education or research? Something happened. I am not a physicist. I am a mathematician. But we have to work in optics. Because to get the camera details, to know about how satellite takes pictures. So what you should do is, whenever you get one subject of interest, you should also look at who are all the scientists. Learn about them, which path they went, where did they study. That's how the universities and all become very famous now. There are places where library, the parking place, it's written that parking only for Nobel Prize winners.
Really? Why?
Because there are people who go there. That shows the status of that library, right?
That only Nobel Prize. Wow.
They can only park.
Wow. What, do they come and check your papers? Like, have you won a Nobel
No,
Prize?
that's
and
not.
park
No,
there?
that shows the status of the place, right? Assume tomorrow you start a cafe shop and then say that only film stars parking space separate or reserved for film stars. So that means your place is generally visited by film stars, right?
Couldn't you just say that and then not get any film
No,
stars,
but
you would
that
get
is not joke. I'm not joking. It's a real one. That means there are places where
Multiple Nobel Prize winners.
winners go.
Wow.
You must watch stories of such people. Highly motivating. List a few Nobel Prize winners, or maybe few great philosophers, few great writers. Have you seen Leo Tolstoy's life story? Documentaries don't miss, my dear.
Who?
Leo Tolstoy. Many writers or philosophers. Whomever, you list down as many.
How do you spell
Tolstoy. Tolstoy. T-O-L. Tolstoy. See, one of the job which I do or which I did for inspiring children. This is my book and Anusha wrote together. Makers of India. So in which different category of people in different subjects. Writer, journalist. These are the people who, so you take physics, science contribution, physics, scientists,
astrophysics, physics, G16.
Now, when you write this, 1,000 people name you are at least reading once, right? Yeah.
Physics is
Read.
Anil Kakorkar.
Leave them. That's not that important for you. That's for Indian people, it's fine. But Homi J. Baba. M.G.K. Menon. Raja Ramanna.
OMG.
Vikram Sarabhai. They're all great people. Space, mathematics. What you should do is look at some names like this and then find out details about them. And if there are some documentaries, learn about them. Fine. Vishwesvaraya, you know who is Vishwesvaraya? A great engineer from India. So it's nice to have some interest, but what you should do?
Learn more.
Learn more about this. Wave patterns. There are people who questions. ECG Sudarshan is one who questioned. Many people say that nothing can be faster than light. He said no. And the quantum physics itself is being questioned.
What are Figo sets that he said that are faster than light? What are they?
Tackle? What were they?
I think they're like.
See, we only talk about light, and everything in this world is related to light. That's a basic thing which we suggested, and anything which has got a wave pattern, the first thing what we say is now what did I do? As soon as I wanted to explain wave, I took light 0.4 to 0.7 micrometer and all that, right? But the frequency can be much higher or bigger or larger than this.
We just can't see it if it's larger or smaller.
Yeah. So just because we can't see, we don't say that it's not there, no?
Ultraviolet.
That's what he proved.
But what are tachyons?
That's a theoretical one.
Oh, it's not real?
He's a theoretical physics man.
So it's just a theory, it's not been
It's a
proved.
theory. It's possible because of these reasons. Most of the things will happen from theory, and then practically people look at it. Some of them are practically done and the theory is derived. Both are possible.
So has a practical thing for tachyons been proved here?
Not done, I think. So you'll be a physicist?
Maybe.
Physics, chemistry, mathematics and all doesn't have borders. Everything becomes equal after some time.
I think physics is...
Now, because just now you said viscosity, right?
Mhm.
What is viscosity?
Chemistry.
It's,
No, it's physics.
it's the thickness or like... I forget. It was... velocity something. I forget. I don't remember what viscosity is.
You are sitting or standing. Why the blood is not going down?
It's being pumped up.
Okay. Do you think it's because of the pumping it goes up?
It's force that pushes through.
Yeah. If there is a force which pushes through, that force is pumping. Correct? So that means when you are standing, your pump has to work more. If you are lying down, the pump will work very less. No.
But
There is something called a capillary motion. You know this?
The little ones
Yeah.
throughout it.
The little ones will. The advantage is because of the little ones, it can go without even pumping.
How?
Because of the quality of viscosity.
Because it's thin?
No. The fluid is such, it has got a viscosity. The viscosity will make capillary motion faster.
And then what is viscosity?
That's what viscosity. Now, assume if I take this water and put a straw, do you think the water will flow up?
No.
It will stay exactly there, right?
Yeah.
But if it is a ghee in which we put, automatically ghee will come.
Really? How?
Because ghee has viscosity.
so would honey do the same thing?
Honey also will do to some extent. Now, do you have a lamp at home in which your wick, the thread which you put is called wick, right? The thread which you put and then light it.
Candles?
The oil will flow up.
Yeah.
Why is it flowing up?
Because of viscosity.
Yeah. Whichever liquid has got
So if
viscosity
you put a straw in oil, will it also come out?
will also come.
So,
And I'll tell you one other example. Assume that I have got water and I pour it like this. Immediately water will fall, right?
Yeah.
Ghee, I pour it like this.
Slowly.
It will think whether to fall or not.
Okay.
That's not joke, it's a science. Therefore it is said, viscous fluid has got more memory. There is a concept called memory for liquids.
Oh, it remembers the shape it was
It
in.
remembers it was at rest. There is you learn momentum, right? Everything has got a momentum to continue in its state of rest or motion unless it is
acted upon
acted upon a.
external force.
So this water knows it is sitting, an external force I am applying, it is coming. But blood and ghee and all, it will say, no, wait. That is why morning your parents will ask you to get up. You why? Because you are a bloody fellow. The blood has got this quality. Blood will say, let mother call, don't worry, sleep. The laziness is due to viscosity of blood. More viscous blood, there can be some slight variation among our blood. Blood is one of the highly viscous fluid. And it is also ferromagnetic fluid. It has got a magnetism. It can conduct electricity. That is why when you touch we get a shock.
It's also why if you have like a light with two silver things and you touch both sides,
That is because the
Really?
electricity conducts.
if you have like a circuit and it has like two little silver plates on the sides and there's a light running through it, you touch both of the sides, the lights will light up.
The electricity goes through you without hurting you?
No, the lights don't have any electricity. It's dead when you're not touching it. When you touch it, it lights
But
up.
when you touch it, does the electricity go through you to get to the lights?
See, you have a normal battery, connect a positive and negative, and you have got a bulb, it lights. You disconnect it and hold both. It will still light.
So the electricity goes through you.
Goes through you.
But it doesn't hurt you?
The small electricity and all doesn't hurt.
Unless it's like lightning or you stabbing a scissors.
So even normal electricity also you can touch and see whether there is electricity or not. But don't touch like this. Touch like this.
What?
Touch like this. Your normal tendency is to bend the finger like this. So you are going to press it faster. Put like this. Normal tendency is to take it back. Even when you touch something hot, don't touch it like this. Touch it like this. Automatically your finger will go like this. But once you put there, you will have to lift it yourself, right? Yeah, that's the difference. Small logic, but makes a lot of difference.
Because your body curls around pain. So,
Yeah, it crumbles and
so if I stab you here, you would do this.
So, similarly, when it is flowing, you stop. Water will stop. But you know what will happen to ghee? You will see it's still flowing. Correct?
Yeah.
Because it has got memory. It has got retardation and relaxation property. As human beings have. Retardation and relaxation. Don't ever do this scrambled writing. Because we are going in a sequence, right? Correct, beta? So when you write in the same sequence, same thing you can explain to someone else. Same thing you can recapitulate. If you write it here and there, you will find a lot of trouble in recapitulating. You don't know where what is wrote, what is this connection, why did I write, all that become. So keep writing. there can be some space going, but keep writing neatly. Your rough note also should be as neat as the fair note.
Okay.
And keep it in your whole life, it will be useful. You may require or you not require, but these are all general knowledge. You are not sitting with some common person. Do you understand? With whom? Who has met somebody, sat in somebody. I am not great, but I have sat in somebody's class who is the person who has done a lot of. We are talking about a subject, I have got something to relate, right? You talk about music, I will have something to relate. Whom I have met, dealt with, seen. You say film, I will have someone who is known to me. You talk about a point, I will have someone known to me. I will tell the life history. Astronomy, astrophysics is your interest. I have sat in his class. Pune. When India government, Prime Minister of India called him to come back to India, he was in US. Jayant Narlekar. So Jayant Narlekar class also I sat. But he didn't teach me physics. He taught me how to build an organization. Because he got a chance to build an organization in India, he built it in a different style. So I attended class where he gave a lecture on how to build a organization. So you are a physics man, you are a great scientist, but you could be an expert in different field. So he is one among them. Vikram Sarabhai is the man who started the Indian Space Research Organization. He was also from America. He was in America after education, working here. Homi J. Baba, Department of Atomic Energy person from India. He was also in America. He was called back. So you will all be called back if you are too brilliant. With all the facilities given. Yes or no? Have you gone to this place? Your Air Force Station Museum?
Here?
Yeah,
Dayton?
yeah. I went Daytona.
Dayton? You didn't go?
In Dayton, Ohio?
Oh no, not Dayton. No, Dayton.
Yeah, it's
I
Dayton.
think so. It's on the way back from New York.
Here itself, not too far.
Oh,
Dayton
yeah.
is very close by.
Here in Columbus? Or no, Dayton, Ohio, right?
Yeah, Dayton, Ohio.
No,
We
I
went to
haven't
an
gone.
Air Force.
I haven't
You
gone.
must.
We went to.
If you have little interest in physics and history, both. Because there is good part of history
I don't
there.
remember where it was.
Huh?
I don't remember where it was. I think it was on the way back
Air
from
Force
Washington.
Immediate task for you. That's the largest in the world, probably.
Yeah, then I think I went to the largest Air Force. Does it have a
It's
bunch
2.5
of Air
hours.
Force?
It's
Airplanes.
2.5 hours. Aeroplanes.
Yeah, I think I went then. A bunch of airplanes lying around.
But going there is not of use if you don't study about it later. When I went, the first question what I had was, how did they took all these aircrafts into that? Is there an airport? There is no airport. How do they get these aircraft there?
Super.
No.
Right.
So I found there is airport.
Okay.
All around there is an airport. This is the museum. There is a nice landing ground. Have you seen? Beautiful. Right?
Yeah.
Yeah. Look at the satellite image. Many people may not have seen this. There is no point in seeing the place when you don't study about it. See? What a beautiful landing ground. And all the aircrafts are got it through this. This is the Air Force Station. So there is a beautiful, if you don't see that also no problem, but today itself you see. Air Force Station, there is a lot of videos available. It will tell you about what they have there on the display. And it also talks about, so physics is one subject, but immediately you have a lot of history, World War One, World War Two, which aircraft is used, how the engines developed. So for every physics man, now when I talked about the physics, I took the year, which year what they invented, correct? And similarly, when you learn any subject, there will be physics plus history. Chemistry also will have history, no? So learn the parallel subject.
Chemistry goes back to World War I and World War II when they invented the gas bombs. I forgot what they're called.
Most of the nuclear subjects also, when you go to the atom bomb, is it physics or chemistry, you will not be able to distinguish. It's both. Okay.
Split the nucleus for uranium.
No, even when you talk about atom, electrons, neutrons, protons, up to that is chemistry.
Yeah.
But when you talk about cutting the electron, neutron, proton, it becomes physics. Fission, fusion, the speed in which, the frequency in which it moves.
Uranium goes to chemistry.
Chemistry.
But then nuclear fusion.
Use of uranium goes to physics.
It's the specific isotope of uranium. Is it uranium 22? I forgot.
140 something.
So what you should have is, you should have sufficient interest in physics, chemistry, mathematics to become a scientist in any of this. Do you know periodic table by heart? Huh?
I know it, but I don't know it by heart.
Do you know there is a song on periodic table?
Yeah.
I've heard it.
But I haven't.
Learn it, You can only learn. I cannot learn at this age. If you can learn, now only you can learn. After some years, you will not be able to learn it. You ask your mother or father to learn it, they will not. At this age, you can. You can make your younger sister also to by heart it. That will be the biggest gift a sister is giving to you. You understood? What I am saying is, a lot of time which you are spending with your children, with your younger ones, use some beneficial ones. Got it?
Forget about Thomas the Tank Engine. Show them the periodic table song.
So invest a lot of time learning about the people, reading something, understanding, using it, discussing that. Good. So what else?
Do you think, I'm just asking, do you think my explanation was sufficient enough?
Yeah, but if you visualize, now you visualize little better, more, right? Somebody asks question, you know how to answer that. Look at it many times. Many people, how do they explain? If you can visualize and you understood what is it, then you can do it. Okay. But most of the time, technical terminologies are very, very essential to explain. So how do you explain now? The whole subject is called electrons. Or what is the essence? Electron can
Go through a barrier.
go through a barrier. Tunnel. So it creates a tunnel. Invisible. You don't know how it goes. That's why it is called a tunnel. Okay. Right? And anyway, the speed is so much. I remember when somebody wanted to. There is no difference between wave and particles.
Wave particle duality.
Yeah. You know why? Yeah, I'll give you some other things to visualize probably that will help.
I think it's because of the Heisenberg uncertainty principle that you can't detect particles' velocity and its location. I think that's what it was.
These are all animations.
We're all familiar with waves, especially water waves. But sound and light are just as wavy, and they're even more common. Luckily, we can learn a lot about sound and light waves by looking at water waves. Here are some continuous circular waves being made by a point source as shown from above, so that we can see their crests moving outwards. We can also show the waves side on, where it's easier to see what's making them. For example, here a rod is being dipped in and out of the water. How would you describe a wave to a friend? We can describe the waves using their wavelength, which is the distance between their crests. It's also the distance between their troughs, because this is the same distance. We'll call the wavelength lambda, which is a letter that stands for L in the Greek alphabet. Now we'll fade out the overhead view and just look at the side view to make the waves look simpler. And here's a boat to show some of the strange properties of waves. How is the boat moving differently to the wave? Notice how the wave is moving left to right, but the boat only moves up and down. You can check this out next time you're in a boat. The speed of the wave is how fast it's travelling from left to right here. It is usually given the symbol V, which stands for velocity. Velocity is another word for speed.
The wave is moving, but not the...
speed
Well,
of
if
the
the boat
wave is
is staying
constant.
in one position, it's just going up
And
and
each
down.
crest moves at the same speed as the
How
others.
This is what I was trying to tell you. It may not be the electron moving here, but the wave is moving so that you feel it is there.
In the middle of its cycle.
That's an illusion, Maya. The word I used was illusion.
This cycling
Maya,
type of
you
movement
remember?
is called simple harmonic
called
motion,
illusion.
and we'll cover that later.
It's an optical
A
illusion.
pendulum is another example of simple harmonic motion, although it moves horizontally instead of vertically. The amplitude of a wave with symbol A is how high it moves up and down compared to a flat, calm surface. Higher amplitudes are caused by the source having more energy and dipping further into and out of the water. The guy on the boat would notice that he would rise and fall more, so he'd get a more energetic ride. The wave's frequency, given the symbol F, is the number of waves being made each second. The frequency is also the number of waves passing by the guy in the boat each second. Here, only one wave is passing per second.
So what you should do is, I asked you to explain to her, right? So similarly, you explain to yourself. Write it down like a systematic note. Record it on a video. And then re-look at it. That's called a micro lecturing. That's what we learn. You record yourself and then re-listen to that as a fresh person. Are you happy with it? Am I presuming something the audience knows? Got it? Am I putting the things in a systematic way? Then listen to that and write down technical terms. Did I presume something this is known, this is not known? Is it correct? Keep doing it. Then only you refine your presentation well. It's like a drama. Presentation is like a drama. You have to rehearse it many times. No, I don't do. Why? Done thousands. So when I say that, somebody says that you have to present it in 3 minutes. And do it in 3 minutes. Same subject to speak 3 hours. I know how to speak it. 3 hours. Got it? So concept is understood, visualize it, write down, put it down into figures, write down all the technical terms, rehearse a little bit.
So how would you explain quantum tunneling within 3 minutes?
Quantum tunneling. If I explain, it will become much more difficult for you. I'll be explaining it more like a spiritual Maya concept. So it is, quantum tunneling is a theoretical physics where now people understood little bit about it, but yet to understand much more. That will be the way I present. I will not say that it is understood by me. It's a concept even today, right? I may take this example, like a person who is on the surface of the boat, on the surface of the wave, the boat goes up and down, and he gets a feeling that he is moving. So there is a question whether an electron which is in a box can come out or not. The basic answer is no. But if it is keep on vibrating, and outside also you see that if the wave was ending there, you will not see that it is moving, right? Correct? There are waves, electromagnetic waves inside the box and outside the box. Therefore, if you keep watching it, you will feel that the same object is there outside. Right? So, it's an illusion, but practically you will see what is inside is also outside. So if you can locate some electrons, very specific, you may see the same pattern there, because the wave passes through the boundaries. So here I don't totally agree with that's why I kept on asking you a few questions. I'm not convinced that I don't just agree with someone. That's my problem. I'm also a scientist. I should not agree. Correct?
Yeah.
But what are the previous videos or competitions which people submitted? Is it
There were a lot on
There was-
CRISPR.
Hmm?
The
There were a lot
gene
of
editing.
CRISPR.
Those are all finalists. The winners, I think last year was on circadian rhythm. The year before was on bacterial resistance and quantum entanglement. The first year they did it, the winner was on like relativity, and then the one in the middle, I think it was on reference frames. So
Did you go earlier? Attended any time? Any one of your friends?
no,
Anyone who is known to you?
no, I haven't.
Is there online available, the presentations and all
Yeah.
that?
Oh yeah, you can.
It's an online video. It's supposed
So,
Here is a cell, the basic unit of all living tissue. In most humans,
But then how do you make the,
Can humans ever learn to regenerate?
what I'm asking is, how do you make
The reason that about
your,
1/3 of you will die
What?
is because the cells in your heart
Yeah.
hereafter can eventually stop.
if you want to show through
Why
something,
can't we regenerate our heart?
You take a video.
Huh?
You take a video.
and then send it to them?
Yeah, it's online.
you take a video, upload it to YouTube, and then send the link to them.
No, but then how do you, okay, show me something which is done earlier. Do they use something on
They use
They use
animations and all that? How
sometimes
do
they
they
have
do
like real
that?
life
That's what I'm
models
asking.
also.
How do they do that?
They learn how to animate.
No, learning to animate or contracting is not a big job, but how do you put that to a person who will make it for you, no?
Breakthrough bleeding. Maybe. Is there a senior challenge too?
Senior? Yeah, the breakthrough was like, the breakthrough is rewarding scientists who make new topics in like math, physics, and biology. The junior challenge is to make a video on a pre-existing concept, explain it better. This was last year's winner.
Ah, a breakthrough that has a far-reaching impact, from boosting grades to even fighting cancer. The answer lies in decoding these facts. Heart attacks are likely to happen early mornings. More Olympic records are broken in the...
You know why early mornings? This is how I'll ask it. You are listening, but I don't listen. That's my problem. My problem is question. See, when you lie down, many of my presentations are on. When you lie down, your blood is moving parallel. All on a sudden you wake up. If you are lying down, nothing will happen. Only when you jump out, you are giving a jerk to your motion. That is the time when you get heart attack.
So then why are Olympic sports won in the afternoon?
Eh?
Why are more Olympic medals won in the afternoon?
That's not correct. That's what I'm saying.
It's not.
No, that is because of this question of our viscosity, electron.
So then when is it won usually?
There are only hundreds of examples which could be. When you speak something, generally you pick up only what you want. Don't consider all these are the perfect answer for every question, right? Assume that how do research happens in this world, when I get somebody who has cancer, my interest is to know that somebody died of cancer because you used to drink a lot of coffee. So what do? I take statistics of all the people who died recently, ask them a question, their family members, do they used to have coffee? The answer is yes. For out of 98 of 100 is yes. Then I will say coffee is not good. It causes cancer. That's how research is. They are all statistics. Nothing proven. Okay. So this cannot be a reason. But anyway, it's an idea, so it doesn't matter.
The afternoon, even my asthma peaks at dawn. Are we just puppets in the unseen hand of time? Welcome to the magic of circadian rhythm. Our body clocks. They regulate all functions like alertness, strength, cell repair, and dictate the best time for any activity. Our chronotype controls our sleep-wake time. For example, larks wake up and sleep early, and owls wake up and sleep late. Most teenagers are owls, but school timings match larks. Hence, starting school an hour later has shown to improve grades. The master clock is a cluster of cells.
Actually, this is not what we don't believe. We believe early hours is the right time to study more. That is one argument. Second argument, for every one of us, we train ourselves. When is our right time? And it's a habit. You decide this is my time, you can do it. You need only 20 to 25 days of time. Because we don't move with respect to the world as animals do. Don't compare animals to us. Because animals don't have light, they don't have refrigerator, they don't have all this paraphernalia which we have. We changed, and therefore that changes our life also. You want to study more? Probably you'll have to have many of them off from your place. Be more active? Yes, you can. You think from tomorrow onwards you want to be active. The same person who is not active, tomorrow assume you have to go for a picnic. Will you not be very active tomorrow morning while waking up? Right?
Yeah.
So it is not you are active or not, it's your interest which makes you active or not.
Cells called the suprachiasmatic nucleus or SCN. It gets reset by light. Organs have clocks of their own. SCN is like their orchestra conductor. When they play in sync, it's perfect symphony.
Again, now I am feeling hungry at 12 o'clock. Do you think you are doing something very interesting? Somebody will say, I feel hungry. You will forget. So the clock is there, but your activity, brain or emotional activity. You are with someone whom you know and you want to enjoy with him, you will forget. You are with your friends, you don't even, but you are at home on a holiday. Definitely 12 o'clock will say, I'm feeling hungry. Correct or not? So the biological clock is there, that is body, but there is an emotion which is controlling the biology more than the biological clock.
The master clock is a cluster of cells called the suprachiasmatic nucleus or SCN. It gets reset by light. Organs have clocks of their own. SCN is like their orchestra conductor. When reset by light.
But good
Organs
video.
have clocks of their own. SCN is like their orchestra conductor. When they play in sync, it's perfect symphony. But each time we have a late night meal, unexpected food messes up the liver's rhythm. Too much gadget light or too less daylight. Cacophony reigns. And with jet lag, say hello to absolute mayhem.
You're going to
Long-term
make something?
circadian dysfunction is disastrous, leading to obesity, diabetes, and dementia. Circadian rhythm is regulated by genes called purr and cry. Action starts with proteins BMAL and clock. They are key to
It's actually highly
activating purr and
expensive
cry
if you
genes.
don't know how to make it.
mRNA moves to ribosomes where purr-cry proteins are
I
made.
think they make on
The
their
kinase protein
own.
degrades purr-cry,
Kids make on their own.
but they gain immunity by pairing up. They enter the nucleus and inhibit BMAL and clock. This stops mRNA production, hence no new purr-cry are made. The last of purr-cry decay, freeing up BMAL and clock to activate purr-cry genes again. This negative feedback loop of purr and cry activation and inhibition powers the 24-hour clock.
With the planetary positions, it gives an electromagnetic effect on the living being. And the universal gravity effect on the minerals are very evident because of the high conductivity which it has got. The electric potential on the higher altitudes are proved to be very, very high. And therefore, the water which flows from the high mountain with the planetary Jupiter, with the planetary positions, it gives an electromagnetic effect on the living being. And the universal gravity effect on the minerals are very evident
So,
because of the
even
high
to make
conductivity
this,
which it has effect on
it's
the
not
planetary
much.
position, the moon and the Jupiter. With the planetary positions, it gives an electromagnetic effect on the living being. And the universal gravity effect on
So here I said it's electromagnetic wave, the same concept, you know. The nature has got an influence on you. It has influence on many of the objects around you. It has influence on the water which you drink. There are multiple parameters which influences you. The people who are sitting also will influence. Assume you are with some person who is very dull, you will also become dull. You are with someone who is very active, definitely he induces some activeness in you. Put it. You must have eaten very not what you really require and you are feeling sleepy, but immediately you get somebody who is a close friend of yours to play some board game. Will you feel sleepy? So what does it mean? This body is one, emotion is another one, intellect is another one, social is another one, spiritual is another one. There are five-fold objects which influences you. So you require to present it like this for 3 minutes and send it to them. When is the last date?
June 15th.
You have only how many days we know?
Yeah.
4 days. You're going to do it? So you can do simulations on this. Somebody's helping you.
Simulations?
You should show electron. Cannot do cut and paste now. You have to do it yourself, right? Or we'll only explain it through drawing and graph.
You could do stop motion.
Hmm?
One of the finalists did stop motion.
Hmm.
Yes.
You can resubmit it after the first screening, second screening, third screening, or change the subject.
I have to wait until next year. I only have one video. But next year I can edit the same video and resubmit it.
For us, okay. So this year, once you submit, it goes up to the final. Different levels, you don't have different options to change.
Once it goes in,
You have to register it in advance?
Yeah.
When did you register?
I think June 5th or so.
Hmm?
June 5th or so.
Why you didn't register?
Was I supposed to register?
this register thing. But anyways,
How many registered from here?
from here, I have no idea.
You have no idea. Okay.
But it's an international competition, so
No, but just to know what are the other person
yeah, I
doing.
don't know.
Okay.
Didn't you say Abby like convinced you to do what I'm telling you? Is she doing it?
No, she's no.
Oh.
She's in India right now, anyways. So
It's international. She could come in from India.
well, she has to turn it in for you turn it in for India.
Me? Why?
Because you have
Oh, who your citizenship is according to that. So even if you live in America, you turn it in from India. Oh, that would be me then.
it's based on where you're from.
Citizenship.
Yeah, because it asks for a photo ID and stuff.
Oh, yeah.
So you are an Indian or
American.
You?
I was born.
Indian.
okay?
I was born in New York.
So anywhere you can submit, no? It doesn't matter.
Yeah,
No?
it doesn't matter.
Yeah.
Because the final
What's
was
Abby?
Abby, American. She was born in Wisconsin.
So it has to be science, it has to be discovery, it has to be a new idea.
Not necessarily. It's just a pre-existing concept in physics, biology, or math. And it can like cross over into chemistry, but it can't just be chemistry. Like you can have biochemistry,
Okay.
but you can't have just chemistry.
Why is that?
Because it's specifically biology, physics, and math.
Oh, no chemistry is there.
My dad probably around 4.
So do 1 or 2 times, re-look at it yourself, then start editing. Time is also important, you know. Within that time you must do it. Your father is here?
Yeah, he's back from Texas.
Okay, so he'll be here next 1 week.
Yeah.
He'll help you?
Yeah.
Who is helping you? Mother is helping you?
I don't know. I've been looking at it myself, and then I was gonna ask both of them about the animation part.
Okay. So you have some people who will do animation here for you?
For me? No, I'd have to do it myself.
Okay.
I did like a couple of
You
stuff.
love drawing or
You know,
what
I
are,
sketch sometimes, not really.
what are you trying to draw?
Nothing. I'm just maybe a tree.
Tree drawing is very simple. Do you do tree like this anytime?
No.
Hmm? Enough or more?
Was that a tree?
Huh?
Oh, and then
I made this animation, so it's like hand drawn. So
Okay. The electron is being bored by.
no, this
Yeah,
was
use the
just an
racket.
example.
Okay.
I was like, what if you're bouncing a ball against a wall and suddenly it disappears and goes through the wall?
Very good.
So
You did it in Flash or
no, it's an animation app.
app is that?
So I did it by hand.
that's cool. I'll have a sketching of a tree I drew once. I think.
No, you want
It's more realistic. Though.
to draw tree. You don't require anything. You can draw like this. Become a tree, right?
Yeah.
But
Yeah,
you
to
want to
make
make it a sand tree. You can make it a sand tree. And the other smaller trees are generally happier, right?
Yeah.
So how does it make?
I don't know.
See the smaller trees happier. The mother tree is sad. The daughter tree is happy. So theoretical physics.
That was the tree engine.
Hmm?
That was the tree.
Yeah, that's beautiful.
Okay.
Pencil drawing.
Yeah.
Hmm.
It took a while.
Hmm?
It took a while.
Good. You need a lot of patience, right?
Yeah, but it was fun and I didn't have anything better to do. And then I drew a cat without its features. The features were too hard, so I just drew the other. I spent so long on that hand. It took forever.
It has 3 fingers.
I know. Because it was like a cartoon hand. Cartoon hands don't typically have all that.
This is my son who drew.
Wow. Pencil? That's
Pencil.
amazing.
Pencil or pen? Maybe pen.
My other cousin also draws.
It's pen.
She draws really well. Wow, that's amazing.
He's running a he's editor of a magazine. It's a Malayalam English combined magazine which is called Ala. Ala means what?
God.
Wave. Ala means wave. So he runs a magazine called Ala.
Is he the one who had a PhD in social science?
He's doing, he's not finished, yet to finish. This is so you must start writing. Keep whatever you have, keep writing. You must make a actual script you made for the presentation.
No, I was making an outline of what I'm going to talk about.
Write down the script in terms of words and see how it flows. And look at technical terms. This is the online magazine. This also he pictured.
He's a photographer too.
He also,
Wow.
he loves photography. You have to go on top of the bridge and then take a picture.
Yeah. I remember those days.
He's the editor for this. Editorial team. Dictionary. Yes,
Yeah.
these equations and all you are going to write down there? Don't recur, no? You recur?
I should probably show it though. But to explain how you get the exponential decay and
Now the equations can be shown only when these equations will you be able to demonstrate at the okay, this component is this component is this.
I have it all written down.
Yeah, but same thing on your pictures animation.
Yeah.
This is power. This one
This entire
potential energy,
thing. This is the entire thing here is
kinetic energy.
of the wave function. I think the only one I don't know is D. That stands for.
What is d there? Where?
Here. D squared times.
Is it d squared times or is it d by dx square? Second derivative of phi and first derivative of x square. Is it derivative? D. Rate of change.
I'm not sure.
Yeah. Whenever kinetic energy is there, what is x here? Yeah. This is the frequency. Energy by frequency. Therefore, this could be the change in what is phi?
Phi x is the wave function.
Yeah. So the wave function, the change in the wave function, the acceleration of the change function, wave function could be.
So this entire part is the change in the wave function.
Yeah. Acceleration or the frequency, the change in the wave function. Whether it is more. You have seen whether the wave can be like this or the up and down is more. Dx square is the x is what? You said you don't know. D, what is x?
I'm not sure either.
Yeah, that could be the wavelength. So the change in the wavelength, and this is the frequency wave. So it could be the second derivative or first derivative, the acceleration or the velocity component of it. Otherwise, these don't match. These two. What is this?
Potential energy.
Potential. Potential energy is what?
The energy it could have.
What does it say? What does it mean?
Potential energy times the wave function.
Yeah, where if wave function, there is a wave. So, whenever you write an equation, do you know what is the meaning of dimensional analysis in an equation?
Yeah, dimensional analysis is in an equation? No.
See, explain it through a simple velocity is equal to what? Distance by
Time.
So what is distance? Meter or centimeter say. Time is second. So this dimension has to be centimeter per second. Then only these dimensions will match. This is the dimension for this, this is the dimension for this. So you can check whether your formula is correct based on the dimension. Here you are talking about wave, correct? Here you are talking about wave. Therefore this has to be wave. Where this is a constant, so this has to be wave. So wave means there is a change. So this has to be the derivatives of the distance or derivative of velocity or acceleration should be here. How was that Saturday Gayatri class? You also came, no? Who forced you to come?
Oh, wait, yeah, my mom.
Sunday. Mom told to go?
Yeah.
Why? Why did you follow that?
Huh?
What you understood? Nothing.
What was the topic again? I can't remember. It was Gayatri Mantra.
Hmm.
And then you told the story about how the Gayatri Mantra came because there was it started with a V and there was an M in the middle. The king, who was friend of the universe, Vishwamitra, went to the Vashishta and he tried to fight him many times and he learned from Vashishta and became a Brahmin or something, and then he realized that it was all because of Vashishta and he didn't want to fight him anymore, and so he created the Gayatri Mantra to protect the people in hard times, because the god said that the dark times were coming. What were the dark times called?
Could be the Kaligal.
Yeah.
You should check what is this. It must be absent.
I found this one on this equation on a different video, and it's the same thing except V is moved to the other side of the equation, and they're grouped together.
Okay.
E and B.
Now generally dou square by dou x square is dou square. Right? Dou square and dou x square shows second derivative and first derivative.
What are derivatives?
Derivatives are, I assume I have got time. I told you, y is equal to mx plus c is the equation of a line. Linear equations are generally done like this. Correct? So here what do you get when y is equal to 1, x equal to 1. Okay? X equal to 2, y is equal to 2. How do I represent this?
Y is equal to x.
Y is equal to x. So here m will become 1. That represents the slope. This represents the slope. So derivative is the rate of change of y. Rate of change of y. That's how the small change is called dou y or dy. Rate of change of delta y. The rate of change of y with respect to x dx or dou x,
So if
which you call it as delta x when it is not continuous. When it is continuous, it becomes dx dy. And how do I know?
What is D do?
Yeah. Dou is not only this, there could be another parameter also. Therefore, it becomes partial derivative. It's called a partial. And this is full derivative. And this is the rate of change. Okay. So here what do we do? What we are trying to say, as x tends to 0, y, what will happen to y? Tends to 0 means, assume this is delta x, no? The delta x is coming closer and closer. That means instead of taking this distance, you keep taking smaller distance. So at this point, you will get a delta y. That means delta y by delta x
Is equal to
as delta x tends to 0. When delta x tends to 0, what is delta y by delta x? The change is not there. Then at that point you have a slope. You are talking about the slope of the line. Now assume line itself is not there. Because delta x goes to 0, line is not the point. So what do you get? You get at each point you will get a
different one?
yeah, that is what is called slope. It is not slope of the line, the slope at every point.
Oh.
But slope at every point can vary. But this will happen exactly same only when the line is straight. Assume the line is not straight. Line is like this. Now delta x tends to delta y. Do you think I will get the same?
No.
It will not. It will keep varying. So for a linear equation, delta x tends to 0, delta y by delta x becomes dy by dx. For non-linear, it need not. Right? So what is dy by dx here? Equal to 1.
because it's 1 over
dy by dx is 1. Here what is dy by dx?
1.
Equal to m.
Yeah.
So that's why this is called the slope. So dy by dx represents the slope. That gives the velocity. Now dy by dx of dy by dx, that is d square y by dx square. What is d square y by dx square?
Oh, because
Second derivative. That is acceleration.
Because y equals can also be mentioned as f of x equals.
F of x equals.
Oh, that makes sense now. So this is basically just the rate of change at a point of time
Yeah.
in the liquid.
So the rate of change of velocity is called acceleration. Got it?
Yeah.
So I can do it on any function.
Okay. Got it.
So here your y is f of x and that f of x is here phi x. Got it? So this is d square phi x by dx square is this d square y by dx square, same way. That's why I said it's a second derivative.
Okay, so that's rate of change at a given point of time.
Rate of change of phi x with respect to x or acceleration of phi x with respect to x is what is shown.